recurrence relations. In this case, we have a tricky question, and usually there's loads of parts when it comes to recurrence relations. I tried to find a question that was heavily algebraic and also includes quite a unique question, which is to do with converging to some value. So what does it say? It says a recurrence relation is defined for m being bigger than or equal to 1 by this expression here. Now let's remind ourselves what this means. It's saying to find the next term, you are doing a lots of the current term plus b. And they're saying a and b can't be 0. They're saying the second term is 176, the third is 248, and the fourth is 284. Find the value of a and b. Remember, all exam technique, whether you're in A-level, GCSE, nursery, is you start with the given statement. They've taught us U2. How does that relate to everything? Well, U2 is what? If this is U2, to find the next term, or U2, you do A lots of the previous term plus B. Well, the previous term would be U1. So U2 is A lots of U1 plus B. And they're saying that is 176. Well, we don't know U and B. We don't know U1. It's not going to help us out here. We can go to U3. U3 is A lots of the previous term, which is U2, plus B, which is 248. I mean, that's kind of handy because we know what U2 is. U2 is 176, so we can actually replace it here. Let's go to U4. So this gives me simultaneous equations vibes. U4 is A lots of the previous term plus B, and that is 284. And again, we know this value. So this is simultaneous equations. So let's rewrite this. Let's look at equation, I'm going to call it 1 and 2 because this is the bigger one. So writing equation 1 again, U3 is 248. A plus B is 284. Then the second equation is U2, which is 176. A plus B is 248. Subtract them. Now, I don't trust myself here. I make way too many videos to trust my mental arithmetic. So we get 72. A, the B's cancel, is 284 minus 248 is 36. Beautiful, mate. So A is a half. Yep. I'm going to write 0.5 just to keep everything on one line. But I generally like writing fractions, to be honest. But anyway, let's sub that into one of them. Let's just do it into number 1. So B is going to be 284 minus a half of this. So 284 minus a half of 248, 160. Part B is saying find U1. Now we can go back to this. We've already done the hard work. So we have, let's call it number 3. So looking at number 3, I have A, which is 0.5, lots of U1, plus B, which is 160, is 176. So you're going to do 176 minus this, and then divide by a half, or times by 2. 176 minus 160 times by 2 gives me 32. There we go. Beautiful. This is the interesting question. The sequence converges to L. Find the value of L. Okay, so what does it mean that the sequence is converging to some value? Now, when we do iteration, and you might remember this from GCSE, we have these recurrence relations. And remember, you let this equal your answer button. And what you guys do is you just keep pressing equals, right? You press equals, 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 equals. And then what do you notice? You notice that the numbers stop changing after a while. It like changes, changes, changes. Then the first part of the question, the first part of the answer stops changing. And then it kind of stops changing as you go along. So what that means is that, you know, you have some value. I'm just going to use letters here. So you have like, I don't know, A, then B, then C, then D, equals, 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 equals. Then eventually, the calculator, from your experience, just stops changing. And this is what it means by converging. It's changing, 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 and then stops changing. Okay? So it's going towards some value. It's similar to how recip graphs, they go towards a particular value, right? So if you keep pressing equals, you know, they go towards that asymptote. Now, how do we describe that in terms of a recurrence relation? What that means is the next term is the exact same as the previous term. All right? So that's what we're saying here. These two values are the exact same, okay? And they're saying it's L. All right? So we're going to say L equals A lots of L, big up Alan that, plus B. But we could just say now that A is 0.5, right? So goodbye Al. Plus B, which was 160. Move that over here, you just get 0.5, L is 160. So L is 320. So it wasn't that hard. The nth term of this particular sequence is given by this. Now this is a deductive formula, meaning U2 is P plus Q half to the power of 2. That makes sense. This half being the same as this A value. Yeah, we're just multiplying these values by a half, but then you just have this plus 160 as well. It just wants you to find the value of P and Q. Now it's quite simple. There's different ways you guys could do this. You could say, all right, U1 is P plus Q times a half to the power of 1. A half to the power of 1 is a half. Yeah, so P plus Q times a half. So P plus half Q is 32. And then you could do U2 is P plus Q times a quarter, because a half squared is a quarter. So P plus a quarter Q is 176 and solve simultaneously. Or you could look at this and you can say, look, as n tends to infinity, as the sequence goes on, the value of un is just 320. Yeah? So it's up to you which one you want to do. Most students wouldn't see that limit. So I'll show you guys both ways. So let's just do u1. u1 is p plus a half q, yeah, when n is 1. And u1 was 32. Then for u2, p plus a quarter q. Yeah, what did we say? We said when you sub in 2, you get a half squared, is 176. I'm going to subtract upwards. We're actually going to get a negative there. So the p's cancel. You get a quarter minus a half. So I actually get minus a quarter here. Q is 176 minus 32. 176 minus 32, which is 144. And I'm just going to times that by minus 4. Minus 576. Okay, wait. Oh no, I skipped some steps there. That's 144, sorry. So we get 144. So Q was minus 576. Okay. Let me just sub into one of these. So P will be 32. Then you're going to do a minus a half. So 32 minus 0.5. Q, which is minus 576. 320. Interesting. That looks to be the limit. So let me show you guys how you could have done this with your limit function. I'll do it with a different color. So what you could have said is as n tends to infinity, I don't know if you guys can see that because that is a pretty trash color. Blue's better. I definitely had a nicer red pen. So we have n. Yo, that's really poor. What are these guys doing, man? Where's my red pen? What about this one? Mate, they're all trash. Guys, I'm just going to write in black. You're just going to have to see it, mate. R.I.P. These guys been abusing my red pens. So as n tends to infinity, what happens? As n tends to infinity, you're doing a half to the power of an extremely large number. You're doing a half times a half times a half times a half. Well, that basically goes towards 0. Okay? So this value is going towards 0. We know that from our geometric sequences anyway. So a half to the power of n tends to 0, which means un is tending to p because this whole thing is becoming 0. But un has a value of 320. So un is tending towards p, which is 320. And then there you go, you get your 320. Then you could sub it in to any of these, which you would have to do this anyway, that you can rearrange to work out q. But yeah, that's how we do this one. Guys, if you learned something today, I'd really appreciate if you hit the like button, subscribe for more maths content. If you want to submit your own questions, feel free to head to the Lund Gang Reddit page. And if you are interested in my A-level maths courses, link is in the description. I'll see you in the next video. Nice.